Solving rational equations. First, we're going to talk about solving a proportion. So step 1, find the domain, set the denominator equal to 0 and solve. Step 2, cross multiply and solve for the variable. And step 3, we want to check for extraneous, which means false solutions in the original equation. So looking at this first example, first I'm going to find the domain. So if I want to find the domain, I set the denominator is equal to 0 and solve, because remember, we can't divide by 0. So that's why we set them equal to 0 to figure out what makes them 0. So here, when we solve, we get 3x equals 5, divide by 3, so x is equal to 5/3. So if what's in the denominator cannot be equal to 0, we would say x cannot be equal to 5/3. And over here, set equal to 0 and solve, so that means x cannot be equal to 2. So solutions cannot be 5/3 or 2. So that means that the domain is all real numbers, but those two, so all real numbers not equal to 5/3 or 2. Another way that we can write that would be negative infinity to 5/3, 5/3 to 2, and 2 to infinity. So now that we had done step 1, we can go to step 2, cross multiply and solve for the variables. And the reason we can do that is because there's one fraction equals one fraction. So when we cross multiply, so I can take the 20 times x minus 2 is equal to 5 times 3x minus 5, and then go ahead and solve. So distribute the 20 here, and distribute the 5, and then go ahead and combine like terms. So when we combine our like terms, we end up with x equals 3. But we need to first check to make sure this is not one of our restrictions on our numbers, which was 5/3 or 2, so it's not. So of course we can still go ahead and check our work by plugging our variable back into the equation. So we get 20 over 3 times 3 minus 5 should be equal to 5 over 3 minus 2. So this gives us 20 over 9 minus 5, so 20 over 4, which is 5. And this gives us 5 over 3 minus 2 is 1. So 5 equals 5. It checks out. And that means x equals 3 is our solution. So let's go ahead and do another example. So for the next example, same thing. First thing we're going to do is step 1, find the domain. So we're going to set our denominators equal to 0. Oops. So we get 3 equals 0 and x plus 2 equals 0. Well, 3 does not equal 0, so that means because there's no variables, that nothing is going to make this denominator 0, but over here we can have x equal negative 2, so the domain would be all real numbers not equal to negative 2, so if we write this using interval notation, negative infinity to negative 2, negative 2 to infinity. So now we can go ahead and cross multiply. So we have 3 times 2x plus 3, and then we're going to multiply x plus 2 times x plus 12, and here we're going to distribute, so that gives us 6x plus 9 equals, and here you have to FOIL out each of your terms. So when we FOIL x squared plus 12x plus 2x plus 24, So 6x plus 9 is equal to x squared plus 14x plus 24. So for this one, I notice I have a quadratic term, a linear term, and a constant term. So remember that means this is going to be a quadratic equation that we're solving. So you're going to want to set this one equal to 0, unlike the other one where we just solved for x. So that means I'm going to subtract, oops, so that means I'm going to subtract the 6x and the 9 to the other side of the equal sign. So minus the 6x here, and then also subtract the 9. And so when I do that, I get 0 is equal to x squared plus 8x plus 15. And again, I did that because I'm solving a quadratic, so now I can either factor or use the quadratic formula. Factoring is a lot faster. So 0 is equal to factors of 15 that add up to 8 or 5 and 3, so x plus 5, x plus 3. So now we set each factor equal to 0 to solve. And then subtract the 5, so negative 5 is equal to x. Subtract the 3, negative 3 is equal to x. Of course, we want to then do the last step, which is to check our solution. So if I plug them in, negative 5 plus 12 over 3 should be equal to 2 times negative 5 plus 3 over negative 5 plus 2. And when I do that, I get 7/3 is equal to negative 10 plus 3 over negative 3. So 7/3 is equal to negative 7 over negative 3. So 7/3 equals 7/3. So it checks out. That means we know this solution works. And so then we're going to go ahead and check the next one, which would be x equals negative 3. So negative 3 plus 12 over 3 is equal to 2 times negative 3 plus 3 over negative 3 plus 2. So that gives us 9/3 is equal to negative 6 plus 3 over negative 1. And so 9 over 3 gives us 3, and this gives us negative 3 over negative 1. So we get 3 is equal to 3. So that means this solution also worked because both sides of the equation are equal to each other, which is what we're doing, just checking our work. So let's go ahead to the next part, solving a rational expression equation. We're going to factor and find the domain, find the least common denominator, multiply the numerator of each term by the LCD, solve for the variable, and check the solutions for extraneous solutions in the original question or equation. So for the first one, there's nothing to factor, so we're just going to go ahead and skip to finding the domain. So if I find the domain, there's no variables in my denominator, so that means that nothing's going to make my denominator 0. So that domain for this would just be all real numbers, which makes it a lot easier. So then the next thing I want to do is find the LCD, least common denominator. So remember, this breaks down into 2 and 2, and this breaks down into 2 and 3. So that means we need 2 2's down here. So 2 times 2 and times a 3. So that gives us the LCD is 12. So if I multiply all the numerators by each term of the LCD, that's going to get rid of my denominators, which is why we do that. So that means I'm going to multiply everything by 12 to all of these. So we get 12x over 4 plus 12 times 2 over 3 is equal to 12 times 5 over 6. And then we're going to start to reduce our fractions. So 12 divided by 4 is 3, so we have 3x here. Here we get, this is 24, so 24 divided by 3 means we have plus 8. And here, 12 times 5 is 60, and 60 divided by 6 is 10. So we get 3x plus 8 equals 10. So the reason that we found the LCD of all the denominators, because then that way when we multiply all the numerators by that LCD, it should cancel out all of your denominators, and then you're just solving an equation. So here, subtract the 8. So we get 3x is equal to 2 divided by 3, and x is equal to 2/3. And then, of course, you want to check your solution by plugging in for x. So if we check, we get 2/3 divided by 4 plus 2/3 is equal to 5/6. So when we have fraction divided by fraction, remember you multiply it by the reciprocal. So if I divide this, I get 2/3 divided by 4/1, which is equal to 2/3 times 1/4. So here we can cancel out a 2, so this just becomes 2, so 1/6. So now we have 1/6 plus 2/3 equals 5/6. How do we combine fractions? We have to get a common denominator, which of course this would be 6, so I'm going to multiply this by 2/2. So that gives us 1/6 plus 4/6 equals 5/6. So that gives us, combine the numerator over my common denominator, so 5/6 is equal to 5/6, so it checks out. So that means this works. Now, of course, that's not the only way you could have done this problem. Another way you could have done this problem is just by making this one fraction, get a fraction equals a fraction, and then cross multiply. That would be fine too. So let's go ahead and look at that way as well. So if I do that, I would get x/4 plus 2/3. So the first thing I want to do is find the LCD of this. So of course that would be 2 times 2 times 3 still, because this is 2 times 2. So that still gives us 12. So that would be an LCD. That means I need to multiply this by 3/3. So if I multiply this by 3/3, and if I multiply this one by 4/4, that gives us 3x/12 plus 8/12. So that means then we can combine our numerator of our common denominator, 3x plus 8/12. And remember that was equal to 5/6. So now I can set that equal to 5/6. And now that I have one fraction equal one fraction, I can cross multiply. So you can only cross multiply when you have one fraction equals a fraction. So in the beginning, I could not cross multiply because I did not have one fraction equals one fraction. So now I can cross multiply. So 6 times 3x plus 8 is equal to 5 times 12. And then you would have to distribute and combine your like terms. So when you end up doing that, you would see that you end up getting the same solution. So when you solve, notice you still get the same solution. So you can do that. I just personally like to get rid of the denominator so I don't have to work with anything in the denominator. But again, you can do whichever method you prefer. So let's go ahead and look at the next one. So again, first we want to find the domain. So here we have an x and here we have an x, so we need to set x not equal to 0. So I know x cannot be equal to 0, and here we get 3 equals 0, but we know 3 doesn't equal to 0, so that doesn't tell us anything, so we only do it for variables, remember? So that means the domain's all real numbers not equal to 0. So in interval notation, -infinity to 0, 0 to infinity. So now let's go ahead and solve this. So we're going to find the LCD of all the denominators, so 3 and x. So that means I'm going to multiply everything in the numerator by 3x. So that means we get 3x times 8/x plus 3x times 11/3 equals -14. Actually, sorry, I should write the 3x first. Oops, I did that for the other one. So 3x negative 3x, I'm going to leave that negative in front, times 14 over x. And so you can see the x's here cancel out, so that gives us 3 times 8, which is 24. Here the 3's cancel out, so that gives us plus 11 times x, so 11x. And here the x's cancel out, so negative 3 times 14 is equal to negative 42. Now we can solve for x because it's not a quadratic, so minus 24. So we get 11x is equal to negative 66 divided by 11, and x is equal to negative 6. And then, of course, you want to check your work. So 8 over negative 6 plus 11 thirds should be equal to negative 14 over negative 6. So here when we do this, we get 7 thirds is equal to, and this reduces into 7 thirds, so it checks out. All right, so the next one, this is over 1. So first we want to find the domain, set each denominator equal to 0 and solve. So here we get x equals negative 3, so that means x can't be negative 3. 1 doesn't equal to 0, so we don't do anything with that one. Here we need to factor. So if I factor, so x squared minus x minus 12 equals 0. So when I factor that, that gives me x minus 4 times x plus 3 equals 0. So x minus 4 equals 0, x plus 3 equals 0. So x cannot be equal to 4, and x cannot be equal to negative 3. So the domain's all real numbers, not equal to negative 3 and 4. So the way that we write that would be negative infinity to negative 3 to 4, and 4 to infinity. So now we have our domain. We need to go ahead and find the LCD of all the denominators. So again, this was x minus 4 times x plus 3. So that LCD of all the denominators would of course then be x plus 3 times x minus 4. And so when I multiply all the numerators by that, so we're multiplying by x minus 4 times x plus 3, so all the numerators, we get 3x minus 5 times x plus 3 times x minus 4 over x plus 3 is equal to 2 times x plus 3 times x minus 4 over 1 plus 8 times x plus 3 times x minus 4 over x minus 4 times x plus 3. Doesn't matter what order you write that in. So here this cancels out, nothing cancels here, and here both of these cancel out. So we're going to go ahead and now rewrite this. This gives us 3x minus 5 times x minus 4 is equal to 2 times, and we know when this boiled out, it gave us x squared minus x minus 12, because that's what we factored right here, plus the 8. So now we need to go ahead and combine like terms. So in order to do that, that means I need to FOIL out the 3x minus 5 times x minus 4. So this gives us 3x squared minus 12x minus 5x plus 20 is equal to, distribute here, so 2x squared minus 2x minus 24 plus 8. And now we can start combining our like terms. So 3x squared minus 17x plus 20 on that side. And then on this side we get 2x squared minus 2x minus 16. And notice this is quadratic, so since this is quadratic, we're going to have to set this equal to 0. I don't like working with negative quadratic terms, so I'm going to subtract the right side to the left side. So minus the 2x squared plus the 2x, and then add the 16. So when I do that, that gives me x squared minus 15x plus 36 is equal to 0. Go over here. So x squared minus 15x plus 36 equals 0. Now, in order to solve this, we can use a quadratic formula, or if we can factor, factoring is easier. So factors of 36 that add up to 15 would be 12 times 3. So x minus 12 times x minus 3. So x minus 12 equals 0. X minus 3 equals 0. So we get x equals 12 and x equals 3. And so neither of these are in my domain restrictions. So that means I would, if I check my work, both of these solutions would end up checking out. So we're just going to go ahead and skip checking the work for now. But again, if you were to check your work, they would both work out. All right, so first we need to find the domain. So that means set each denominator equal to 0 and solve. So this, remember, you can solve two ways. You can solve by factoring because it's a difference of two squares, or you can add the 16 and take the square root. Doesn't matter. So if I factor x plus 4 times x minus 4 equals 0, so when we saw we would get x equals negative 4 and positive 4. And then here if we solve x plus 4, we would get negative 4, and here if we solve x minus 4, we get positive 4, so that means the domains all real numbers not equal to negative 4 and positive 4. So in interval notation, negative infinity to negative 4, um, negative 4 to 4, and 4 to infinity. And if we go ahead and find the LCD of all denominators, remember this was x plus 4 times x minus 4. We have 1 here and here, and 1 here and here, so that would be x plus 4 times x minus 4 for the LCD. So when we multiply that by all the numerators, we would get 6x squared times x plus 4 times x minus 4 over x plus 4 times x minus 4 minus 3x times x plus 4 times x minus 4 over x plus 4 equals 4 times x plus 4 times x minus 4 over x minus 4. And we can cancel out our factors. Remember, we did that on purpose by getting the LCD of all the denominators, so we can get rid of the denominators by multiplying the numerators by that. So this gives us 6x squared minus 3x times x minus 4 equals 4 times x plus 4, and then we're going to go ahead and solve. So 6x squared, distribute here, minus 3x squared plus 12x is equal to 4x plus 16. And then we're going to combine our like terms. So when we combine these, we get 3x squared plus 12x is equal to 4x plus 16. Notice I have a quadratic term, linear term, and constant, so that means we're going to want to set this equal to 0 and factor, use a quadratic formula, so minus 4x, and then also minus the 16 to the other side. I'm just going to put it over here because I don't have a like term with it. So that gives me 3x squared, and then 12x minus 4x is plus 8x, and then minus that 16 equals 0. And then we can go ahead and factor this. So this has a 3 in front. There's no GCF, so Swedish fish don't really swim. So x squared plus 8x minus 48 when we multiply 3 times the 16. And then we want factors of 48 that add up to 8. So x minus 4 times x plus 12 and then divide by what we moved in the beginning, so divide by 3, reduce, and if it doesn't reduce, swing it in front. So 3x minus 4 times, and 12 over 3 becomes x plus 4, and then set each factor equal to 0 to solve. So 3x equals 4, and x equals 4/3, and here x equals -4. So remember we said that one of our domain restrictions was that we could not have -4. So that means this is an extraneous solution. And that means that 4/3 is my solution. And then of course I could always check my work by plugging that back into the original equation and solving. And that's it.